Our presentation is going to be broken into two parts, so I'm going to set some context and give you some background. PSG, as you may or may not know, is a group within Synergex, our department, that focuses on application development. We engage with our clients to provide software development resources focused on extending and expanding their applications. About 3 years ago, I think it was 3 years ago at the conference, Steve Ives presented a session on unit testing, which I was very interested in, showing how Visual Studio could be used to automate testing and make it a consistent part of a software development process. During this past year, PSG has been working with turnkey computer systems right here, helping to refactor their software to allow end-tier client-server deployment, featuring a new Windows Universal User Interface. As part of this project, we've incorporated some of the concepts first laid out during Steve's original presentation. Let me set some context and describe unit testing from our perspective, which may or may not agree with some of your perspectives, but for the sake of this conference, let's talk about how we see unit testing and how we implemented it for this project. What is it? Why are we doing it? And when in the software development lifecycle process do we implement it? Here's a definition of unit testing that I'd like to propose. Unit testing is a software testing method by which individual units of source code, together with associated control data and procedures, are tested to determine whether they are fit for use. So 3 parts of unit testing for our purposes. Number 1, we have the software, the source code of a small piece of software, one task. We have the process. How do we want to test it? How should this thing behave? And we have the data which it acts upon. So 3 parts, part of the components of unit testing for our discussion today. Typically written by software developers. So it's going to be early in the process, written by software developers to ensure that the code meets the design and behaves as intended. It actually reduces the time, we find, when done early in the process, reduces the time by the whole software development cycle by ensuring that individual components that comprise the system are operational before they're tested together. So we look at it as the foundation of testing to be done early, built upon an integration test of multiple units, and then finally a system test that comprises the entire system. Why do we do this? Well, that's obvious, right? It improves the quality of our software, okay? By finding problems early in the development cycle, this includes bugs that a programmer may include or may not. It also includes errors in the implementation of the specification. So it finds where the changes are, it finds where errors are, not only in code, but possibly in specification as well. So the process of writing a thorough set of tests forces the author to think about the inputs and the outputs and the error conditions, and thus better define the unit's behavior. Obviously, the cost of finding a bug before coding begins or shortly thereafter is considerably lower than the cost of detecting, identifying, correcting a bug after it's been deployed. So, improves the quality of our software, builds robust, reliable software, which leads to lower costs overall. Refactoring is one of these buzzwords that has been flying around PSG for some time. So what does that mean? It's taking a monolithic piece of software and dividing it into the layers, the typical layers of a software system, the data, the business logic, and the user interface. So we take an existing system and we help our clients leverage the value of their software, of their business rules and their data by separating them into layers. Unit testing is really useful in this role because it allows us to test the business logic at a component level. It also facilitates change by, once you have a unit test, to group the unit tests into and use for regression testing, to make sure that later on in the cycle, a change over here doesn't impact a change over here, and if it does, it helps us find those issues. Another aspect of unit testing is that the use cases that are developed can be used as kind of a piece of documentation for the system, for programmer-focused documentation, right? Because the test cases embody the characteristics that are critical to the success of running this piece of software, okay? Again, can indicate appropriate use of the module, as well as negative behaviors with the module. So it's not the be-all and end-all of system documentation, but it does have a value, and it can be used. The test cases can be used as a kind of documentation as well. What do we unit test? So in our refactoring, we're making these modules of small bits of code that do specific things. So these are the things that we're testing at a unit level, okay? The idea is it can be run independent of all tests, but it can also be grouped to form a more complete test. As we said, data is an important part of our definition of unit testing here. We have a process by which we'll take a known data set and reload it every time we begin a unit test to give us a known starting point, okay? Again, where this is really useful is testing our individual units, but also later on to be able to test units together and use for regression testing. In this particular project, we're doing unit testing after the software has been written. After the code's written, we're doing the unit test. And passing the unit test indicates that the code is ready for delivery. This is kind of a standard way, very common way that unit testing is done. However, in test-driven development, the test is made before the program is written. Before the code is written, we come up with the test. And by defining the test first, you then implement the test when you write the code. So you think about what the test is, so it leads to better quality. So writing use cases before actually writing code. Then the test case becomes the specification, if you will, for the unit of code. If the unit tests fail, it's a bug either in the code or in a test, but you can use this, again, for writing before the code is written. This was a slide I stole from Steve, actually, the earlier presentation, which is a great repository for information from 3 years ago. So the concept is, hang on, you think about how the module will be used because the unit test has to use the module. So it's kind of a circular thing. And that is the key to test-driven development. So that's the kind of context, that's the setting by which we're coming into doing this refactoring project. We're going to talk more about the front end later and do a demonstration. But now I'm going to turn it over to Kish, who's going to show how we applied these concepts within Visual Studio for this project.
Thank you, Don. All right, so what I'm going to do is kind of go into a little bit of detail as to what, how we implemented unit testing specifically for turnkey. As Don mentioned, it's an active engagement for us. It was actually something that came into being a little bit later in the process than we would have liked, but knowing what we know now, we firmly believe that on future engagements, unit testing should be something that's part of the project from the very beginning. As Don mentioned, the project for turnkey involves refactoring some of their legacy software. Some of that legacy software is decades old. So what we're doing is basically taking the traditional Synergy code and refactoring it in Synergy.net within Visual Studio. Since we're using Visual Studio, we can easily incorporate unit testing in our solution, and that's exactly what we did. So before I get into the demo part, kind of talk a little bit more detail about what makes up a unit test framework. We call it a framework, you can call it a project, you can call it whatever, but there are some key aspects of what a unit test should be. First of all, there's got to be functions, methods that actually perform the tests themselves. In Visual Studio, those methods have to be attributed in some way to tell Visual Studio that this is not a normal method within the application. It is in fact a unit test. And by attributing the code, you'll be able to see it in certain places that you wouldn't normally see your normal code in. We use the concept of grouping our test methods into what we consider to be logical groups. And we'll go into a little bit of detail about that. The nice thing about, I think, the way that we undertook the particular grouping aspect is it's very easy to modify. It's within the code. Again, it's within, with attributes within the unit test methods, and you can make up any grouping that you want. So you're not limited by anything that's available in Visual Studio or anything of the sort. Each unit test is going to have some sort of a setup and a teardown, as well as the actual test methodology itself. And the way that the Visual Studio unit test project is defined, it's easy to be able to create class initializers, test initializers that will perform some function for you before each unit test runs in turn. And then the same thing on the back end. As it's shutting down, you can do some file cleanups and that sort of thing. So we'll see some examples of that. The actual unit tests are stated as assertions. So within Visual Studio, there's actually an assert command that you can call to perform some sort of a test. And the assert command returns either yes, it's valid, or it isn't valid. If it's valid, then it will continue on with the rest of the code, and then hopefully you'll have multiple asserts that test a variety of different things of the method, the particular method that you're testing. So once an assertion fails, the test method stops. That's it. You're done, and it displays the particular error message. If you have multiple asserts and all assertions pass, then the test passes, and you also get a nice little message in the Test Explorer that explains that everything's good. So what I'll do is I'll go through a little demo here. We will show you exactly what we created. I'm not going to dive into a lot of the code. I'm going to dive into the code that's pertinent to unit testing. So first off, over on the left-hand side here, there's this Test Explorer, and the Test Explorer really shows you the universe of test methods that you have available to you. These are all methods that you create based on the individual methods that you're attempting to test. By default, the view so when you add one of these test methods, and that's the project right there. I don't know if you can see that or not. We actually created a project that we called Test Harness for lack of a better term. And the way that we did that, we simply went into the solution and we said add a new project, and one of the options within the Synergy DE template is a unit test project. So that's all it is. When you add a unit test project to your solution, it creates a very small template that you then expand upon. So that unit test template is available within Synergy. So again, back to the Test Explorer. By default, when you first come in here, you just have a list of every single test method that you've created. And you can see that I ran all of them. There's happens to be 718 that we've created so far. And I ran this, and just a couple of points I want to show out. Anything that fails, big red X, kind of a warning, for you that you got to do something with that you failed because your expectations were incorrect, the code has changed underneath you, or the data has changed underneath you. So you got to do some research to try and figure out what all has occurred. All the fails are always going to be at the top. Then you've got some warnings. I'll talk a little bit about these warnings here within the code itself, because we use an assertion called inconclusive to actually put a marker, a placeholder for us that says we have yet to write a test method for that particular unit test. So it's a good way to be able to keep track of, have you completed the unit test for this method or haven't you? And it's a visual cue that You got to finish those. And then after that are going to be the green check marks that says everything is good. Your unit test ran just fine. So again, this is the default view. It's kind of hard, at least for me, to try and determine, well, which tests go against a particular report, a particular business logic, maybe some data access methods. And so very early on, what we decided to do is within the Visual Studio Test Explorer, you have the option to group these test methods by certain things. The default is either class or project. I'm not sure, but they basically look the same. It's just a whole list of information. What we decided to do is go ahead and add some traits to our test methods, and which allows us to organize our tests by specific groupings. And again, as I mentioned earlier, the groupings are things that we define. So there's nothing that says you have to use the word group. You could call it AR if you wanted to group your accounts receivable test methods within that group, or anything else that you prefer. And the other thing that we'll show you is in fact a particular unit test can exist in multiple groups. So you can organize it in different ways. The way that we organized it at Turnkey is that they have these major groups that they call business logic, or BL. DA is for data access. So they've got methods that only do data access. Go and read one or more records from a file and return a collection. All right, and so we decided it makes sense to group those at those top level groupings to be able to say, hey, we made a change to some low level functionality in the way that we retrieve files. Well, the one that we want to test out would probably be the data access layer. And also it provides you with a hierarchical means of testing, because you probably want to test the data access layer first, because the business logic depends on that. And then you test the business logic, and then you test anything else that uses the business logic. So we've grouped it in such a way. And then within each, we also take each method and define it as a subgroup. And that is more along the lines of what you would typically think of as your various systems, your accounts receivable. In this case, they happen to be specific programs that we're doing. But there's nothing that says you have to do it this way, versus another way. So I mentioned that the advantage of using the unit test project is you have this shell that is created for you. Unfortunately, it's fairly empty when you first start out. Maybe that'll improve down the road or what have you, but for the most part, some of the things that you do want to incorporate into your test project are things such as class initializers, class cleanup, test initializer, test cleanup. These are all things these are attributes that are available within Visual Studio that you can then attribute your code or your methods against, and it will know what to do based on that attribute. So the first attribute that any test project has to have is this test class. You're defining that this in fact is a test class, and that then tells Visual Studio that, all right, things in that test class are going to show up in the Test Explorer and nothing else. The other thing that I want to kind of point out here, and this didn't become obvious to us right away, is we're making this class, we're calling it TH, or short for test harness. We're making it a partial class. That allows us to basically create our unit tests and have it use the methods within this TH class, such as the class and test initializers. And we also happen to have some private methods that we use to allow us to write log files, do timing, so we can time each one of the test methods in turn. So it helped to make it a partial class and then have the unit tests themselves share that same partial class. For those of you that are familiar with .NET programming, pretty straightforward. You got constructors, destructors, properties. I'm not going to go too much into this. Suffice it to say that a class initializer starts at the very first. So if you're going to run a series of tests, it will run the class initializer first at the beginning of that run. What we did with the class initializer is we said we're going to do some logging. So, basically what this code does is it creates a log file if it doesn't exist. If it does exist, it appends to the log file, basically telling you, hey, you started the test on such and such time, and there may be some, well, in this case, it's just a header to that log indicating when it started. We also do some things like in the particular case of Turnkey, they have a device file, and I think that's, some of you may be familiar with that because that's quite common. A device file basically tells the system, what the AR accounts file is. It's device number such and such, and then their system actually uses the device number. But it's a way for you to be able to add code that you want to run at the start of every test run. Also, the class cleanup is basically just saying at the end of the log file, okay, the elapsed time for this particular run was, and then we'll do some code cleanup. We'll actually do some delete files here, even though we also do that within the test method themselves, because if you recall, if an assert fails, that's it. The code, the unit test stops running at that point. So if you have any code cleanup, as every good programmer, if you're going to create files, you better clean them up, you should have, this allows that cleanup to occur. So you don't have any files that are left over that may interfere with the next run. The test initializer is just something that runs at the beginning of each test, not the run like the class initializer, but the beginning of each test. And all we're simply doing here is we're starting a stopwatch, because all I care about is at the end of that test, how long did it take? All right, and I will write that to the log file. And then, as I mentioned before, we then have several private methods that each of the unit tests in turn will use in order to be able to write logs, copy files, delete files, and what have you. Let's take a look at an actual unit test. So this is really just the infrastructure that allows us to be able to use some of the tools to write our unit tests. First thing that we'll look at is the actual method that we're going to write tests for. And I've just collapsed them. There's no real reason for us to look at the details of any of this stuff. But suffice it to say that we have this thing that we call lot.dal. It's a class called lot.dal. And what it's doing is providing methods to our system that allow us to do data access type calls. So there's a method in here called getReadFile class, readActive by lot. You'll notice that there's an overload to readActive by lot, and so on and so forth. So those are the methods that we created. That's the refactor work that we did, and that's what we want to test. The test method itself is going to be this thing. And if you notice, the file that we're going to test against is called lot.dal.select.dbl, and the test methods, the source file for the test methods, kind of reference that name. So it's lot_da test, kind of self-explanatory. Again, here we have public partial class th. So now, because it's a partial class to the th.dbl, we can then call private and public methods, basically all the members that are available in the th class. Each test method, just like you have to attribute the class with the attribute test class, each test method has to be attributed with the word, or with the attribute test method. That again tells Visual Studio this is a test method, go and display it in the Explorer. The test property, and if you notice there's a couple of them here, test property is really just a dictionary. It's a key and a value. But by defining the properties, you're telling the Test Explorer, organize it by these. So as I mentioned earlier, you have these particular methods happen to be in this thing called group, and it's a data access type of a test. So we're going to define that, and every single one of these methods belong in the DA group. And then we also have a subgroup that says these are the tests for the lot data access, which is not the same as your item master data access. All right, so it allows us to organize things that way. And again, as I said, so here's group DA. Somewhere in there is going to be the actual lot test methods. All right, so you see that there, but I had to scroll down quite a ways to be able to get to that. And then within, you can see all the DA type methods, but then also if you wanted to run just the lot DA test methods, here they are. So it's a much smaller group and allows you to be able to say, you know what, we only changed this section of code. There's no reason to test everything. And oh, by the way, I don't know if you see this or not, but about 718 tests in the group took 4 minutes. 4 minutes, 12 seconds to run. That was the other reason why we wanted to add the timer, because we found out very quickly that certain methods took a long time, much longer than what we expected. And so we said, well, we can't turn that over to the customer because they have an expectation that it's going to run with a relatively short period of time. So we were able to catch that before turning the code over. The code ran fine, it tested properly, but instead of running for 3 minutes, we needed it to run in under 10 seconds. All right, so very quickly you can see those things, and because you're creating the unit test in conjunction with writing the actual methods, you can very quickly go back and say, this is what I need to do, whatever the fix needs to be. So the other thing that I wanted to point out here is that there is a one-to-one relationship between the test methods and the things that we are testing. There's a read active by lot, and here's a read active by lot. Here's another read active lot, and that corresponds with this one. I won't go through the reason why there's overloads. It's something that's unique to what we're doing with Turnkey. So basically, this is a one-for-one. It matches exactly what's going on. And then at the end here, as I mentioned, we happen to be in read data is one of these things that it would be difficult for us to set up. So we simply put an assert inconclusive in here that says, hey, when you run me, I'm going to show up on Test Explorer with that yellow triangle that says I'm not complete. So it's a visual indicator, because if you didn't have that, the Test Explorer would say, okay, everything's good, okay? But this is a visual indicator that tells you that you haven't yet written the actual tests for this particular method. So it's just a reminder as you get along that, hey, you need to clean up all of those yellow boxes along with any red X's. So it's a good idea to include those right away in your code, and then as you write the test methods, then remove that inconclusive test that tells you that the code is complete. So the actual test methods themselves, we'll take a look at one just real briefly. This happens to be for a report. Again, this should look pretty familiar to you. The difference here is that, or at least the thing that I wanted to show you. So within each test method, so this is a method called build report within the lot summary report program. So the prep work that we're doing is because this particular report requires a lot ownership, a lot master, some transaction history files. What we're doing is in fact copying those files from this base set of data that we have, a static set of data that we have, and copying it, essentially giving it a different file extension so that when our unit tests run, they run against the copy. The static file remains exactly the way it is for every test run, and we just simply copy the test files for the unit test to be able to use. That way, if you have a method that actually updates the file, you're only updating the copy, which is going to get deleted at the end of the unit test. And that's exactly what it's doing here. So at the end of the unit test, we're just basically backing out all of those test files that were created. They may or may not have been modified. We don't care, okay? And then the actual test methods, we tend to define input values, what we expect, in return, and it's very important to do that. You have to write your expectation rather than just simply saying, well, let's go run it and see what it spits back. You have to kind of understand what you're expecting to return back. And again, we call this thing something build report, and in fact, if you take a look here, we are executing this method called build report in the lot summary report. And then after the method is invoked or executes, it's going to come back with some data that either we can query the ISAM file directly, like if it updated, if all it did was update the ISAM file, and not return a value through the method arguments, we'd have to query the actual ISAM file to determine whether it did anything or not. The more asserts that you can include in your unit test, the more likely that you're going to catch when a change occurs, again, either in the data or within the code itself. So it's always a good idea to have a lot of these asserts. I'm not going to go into all the details of what assert types are available. We mostly use, is it true or is it false? All right, and you can always look up that information, or if you want to ask us, we'll be more than happy to talk to you a little bit about that. But the whole point of this thing is really to provide a shell that you can use within your Synergy application. As Don kind of mentioned, Synergy applications that we write tend to be data intensive. So it's not a matter of just simply saying add 1 + 2 and give me the result. It's usually go and read these records and update this field in some of the records. So we really need this facility to be able to say, we've got this static set of data, and when we run the tests, it will always use the same static piece of data. So quickly, just some of the lessons that we learned. I didn't really talk about it, but there's this thing called playlists. We very quickly found that creating a playlist involved managing that playlist, and to me, it just wasn't worth the time. It was much easier to simply attribute the code with either a group or subgroup or whatever you want to call it, and allow it to group in that way. The initialize and cleanups, you can do things like timers, loggers. In the case of the cleanup, don't forget that when a unit test fails, that it's not going to complete the rest of the code. So you've got to clean up things like the files that you may have copied. We're not going to worry about nested private methods. Overload methods, if you do use overload methods and you use the similar naming convention as we did for the unit test, you're going to have to account for that, because you can't have an overloaded unit test. At least I wasn't able to create it. And then again, when you're creating your unit tests, try to create all of your unit tests and have an assert inconclusive in each one, so that you know that you've yet to write that code. We already mentioned the Synergy apps being data intensive. Again, one of the big benefits that we saw very quickly on this was that we could have turned code over that would have been inefficient and slow, but by having the unit test, we were able to determine right away that we got a problem here and we need to do something about it. What that something is can vary with your particular test method or your actual method. And as just kind of a recap to what Don mentioned, a lot of this is based on a tutorial actually that Steve Ives did a couple years ago, and so I highly recommend that you take a look at that when you get an opportunity, because a lot of what we talk about here is detailed out in what he did 2 years back, 3 years back. So just a kind of in review, I think it's important that you create the unit tests in parallel with your new code. For developers, it's difficult for us to write it beforehand because we don't understand what the code is that we're trying to refactor, but try to write it as soon as you write the actual methods themselves. You saw ways to be able to organize it. Unit tests are a living, breathing thing. Refine and add to it over time. And then, write the unit tests in such a way that with the intent that you're going to run those tests fairly regularly, nightly, so that you're always, realizing that, something changed, somebody didn't report it to me, but, the tests that, indicate that something changed, and you can then figure out whether somebody changed the data, somebody changed the code. So finally, what's available with Visual Studio Professional with this test manager, very limited. Somebody that with a QA department might want to consider something like a Microsoft Test Manager. There's other test systems that are available out there that have far more functionality than what's in the can in Visual Studio Professional. So,
as Kish mentioned, this is in our refactoring projects, we feel very strongly this is part of every project that we do now. And as was mentioned in our previous presentation, Synergy plus Visual Studio equals an awesome dinosaur. And we are going to make this thing part of every project going forward. So I appreciate your attention during our presentations.